Okay, so we're going to talk about section 7. Section 7 is all graphing. So I think, wasn't Thursday's homework all graphing too? Most of it was graphing? Okay, this is going to be really awesome to have a video of me in this outfit. Can't wait. You guys wanted costumes, here it is.
You should do like a nerdy voice.
Please
I
do.
know, and like,
Okay, so we're going to, you're going to have equations. This is going to be the only parts that you have to do. We're going to identify the parent function. We're going to describe the transformation. We're going to then graph the parent function and the transform function. Okay, if you did not take notes off the video on Thursday, I'm going to talk about parent functions and transformations. Everything I talk about is going to refer back to those notes. Okay, so you might want to make sure, even if you don't listen to me, you go back and watch the screens that have all of your parent functions written down. Okay. Okay, so a parent function is if you take away all the adding, all the negatives, subtracting, and what you're left with. Okay, I don't want you to describe it. I know this is a quadratic. Okay, but for the parent function, you're actually wanting to list the most basic function, which is x squared. So it's leaving the variable but taking away everything else. That's your parent function. Okay, and this might actually help you on Thursday's homework as well, because this is like one step forward from that, but you can kind of go backwards to do that. Okay, B is describing what's going on. So then I look from here's my parent function, what do I have going on from here to here? Well, I have a negative in front of the whole thing. Okay, then I also have a plus 4. Well, if you look at your transformations, a negative in front of the whole thing means it's reflected over the x-axis. Does anybody know if you add 4 out on the outside, what it does? It goes up 4. So somebody was asking me the other day, what does inside and outside mean? Inside would be like inside parentheses or inside the absolute value or inside the square root. If you don't see anything like that, this would be on the outside. Okay, then part C is our graphing. What you're going to do is you're going to take like a regular T-chart. Now, this is a quadratic. We're going to graph the parent function first. So, unless you're doing a square root, I want you to use these 5 numbers. If you're doing a square root, you can't take the square root of negatives, so you would start at 0. Okay, and I'm going to plug those into my parent function. So you're plugging these in to this one right here. Okay, so what is negative 2 squared? 4. Negative 1 squared? 0 squared? 1 squared? 2 squared? 4. Okay. And we're going to graph this. When we graph it and we connect the dots, we're going to make this a dashed line. So if you want to go ahead and draw your coordinate plane. So when you do your parent function, you're going to plot the points and then make it a dashed line. reflected over the x-axis, you have to do this first. If you see reflected over the y-axis, so I'll put that up here, if it's reflected over the y-axis, then you do that part last. So what we're going to do is we're going to take each one of these 5 points and we're going to do what it says in our transformation. So it says we're going to reflect over the x-axis and then we're going to move them up 4. Okay, so reflect over the x-axis comes first. Which one's your x-axis? Okay, it's your horizontal one. So if I reflect this, I'm now down here. And then what do I have to do also with that point? You have to go up 4. So 1, 2, 3, 4. So that's really going to be right here. So we reflected it. There's 4 ways. We went down here. But then it says we have to go up 4. So 1, 2, 3, 4 puts me right here. Okay. So then I take the next point. If I reflect it, I'm down here. And then I have to go up 4. 1, 2, 3, 4. That's me right here. Okay, if you're reflecting something that's on the axis, it stays there first. So if I reflect it, it still stays here, then I gotta go up 4. So my point goes here. So I do that at every single point. So I reflect this one, up 4. Reflect this one, up 4. Okay, and then this graph you're going to do solid. So your parent function will be dashed, your regular function will be solid. Okay, and that's what you're going to do on every single problem on your homework today. We're going to do some more examples, but. Okay, so the first part is we identify the parent function. So that's if I take away all adding, subtracting, negatives. Okay, then we describe what's going on. This is reflected over the x-axis, up 4, and then we graph them both. Pretty good? We did this in Algebra 2 as well. I don't know if you remember it. Anybody remember from Algebra 2? No. You guys just don't want to talk because the... Am I right? Yeah, you're all over. Okay, so part A, what would my parent function be? It would be a cubic, so it would be x to the 3rd. Okay, so we take away everything else. Don't write cubic, I want you to write the actual equation. Okay, then part B, we're describing the transformations. So I'm subtracting 1 on the inside. So if you go look at your transformation rules, that means we're going to move right 1. Okay, adding 2 on the outside means we're going to go up 2. Okay. And then for part C, our t-chart is going to be off of our parent function. And unless it's a square root, I want you to use these 5 points. Okay, so negative 2 to the 3rd is negative 8. Negative 1 to the 3rd is negative 1. 0 to the 3rd, 0. 1 to the 3rd, 1. And 2 to the 3rd is 8. Okay, so go ahead and draw your coordinate plane. And we're going to make this dashed. this graph doesn't have anything that's reflecting. So if you're not reflecting anything, it doesn't matter the order. Okay, so do you want to go right first then up, or do you want to go up then right?
Right.
Okay, so we're going to take every point and we're going to move it right 1 and up 2. So we're at this point down here. We're going to go right 1, up 2. That's our new point. Take this one, go right 1, up 2. Okay, so I did this one, right 1, up 2. This one, right 1, up 2. We're going to do the same thing with this one, that's 0, 0. So I go right 1, up 2. Right 1, up 2. Right 1, up 2. Okay, now these should make the same shape. So make sure you're connecting, pay attention to your new dots. So it's still a cubic, it's just a little different where things change over. And that one will be solid. How you feel about these so far?
Fantastic.
Fantastic? That was a little sarcastic. I know you guys don't like graphing, and that's why you're only going to do 6 of them on your homework. Okay, you want to do one more example or 2 more examples? One? Do you want to do an absolute value, or do you want to do a square root?
Square root.
Square root?
How about 2 more?
Yeah.
Want to do one of each?
Yeah.
Do you know what your transformation is if there's a number in front that's multiplied?
Oh, like,
Yes.
Okay, it means it's stretched or compressed. Do you know how you know the difference?
It's a
if it's a fraction.
If it's a fraction, it's
compressed.
compressed. Okay. Now, if you see a problem like this, I'm not going to do an example like this because I think you might only have one. It doesn't change anything except for if this number, if there's a number multiplied in front and it's a fraction, so this is a fraction, this would be compressed by a half. What if it was like a integer? Then it'd be stretched. So this one would be stretched by 3. Okay, it doesn't change anything about your points, how things are moved. I just want to make sure you know that. Okay, if you see something like that. Your bunny ears. Okay.
Did you hear what she told me?
No.
Should I say it? She said, you said, you can be my daddy function, but don't act like you're my parent function.
Wow.
It's all on video.
Everybody will be able to hear it now. We'll have Okay. What's the parent function for this one? What's our parent function? As the value of x. Okay, what does adding on the inside mean? Anybody know? Plus 3. What does that minus 2 out there mean?
Down 2.
Down 2. What do absolute value graphs look like? These. Okay, so when I go to graph, that's part C. So if I do my T-chart, okay, so I plug in -2. What's the absolute value of -2? 2. What's the absolute value of -1? 1. Remember, so absolute values come out positive. Absolute value of 0. Absolute value of 1. and absolute value 2. Okay, these make these. And remember, it's always positive, so you're not changing the sign unless it's negative, because it means the distance. So I have negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. Okay, so we're going to take every point that's on our graph and we're going to move it left 3 and then down 2. Everybody okay if I do that? Not yet? Yes. Okay, so if I start, I always just work left to right. I don't care, it doesn't matter as long as you get all the points. So I'm going to go left 3, 1, 2, 3, down 2. Left, 1, 2, 3, down 2. This one left, 1, 2, 3, down 2. 1, 2, 3, down 2. 1, 2, 3, down 2. Okay. And then this is my new graph. Good?
Yeah.
Okay. I'm going to do one more because they wanted to see a square root. Guys ready? Okay, what do you want? What do we put in it? You care?
No.
Let's go with the basic one. I'll just grab it by hand. Okay, so what would the parent function be for this one? Square root of x. Okay, and I have a +1 and a +2. So what does a +1 mean? That's 1. And what does the +2 mean? Okay, with square roots, you cannot take the square root of a negative. So when you're doing part C, before you graph it, you're making your t-chart, you start at 0 on these. Okay, now, square roots, not all square roots are perfect. If you want to use like decimals, you can. But if you want to plug in perfect numbers, then I would use 0, 1, 4, and 9. Those will give you your perfect numbers. Because what's the square root of 0? What's the square root of 1? Square root of 4? Square root of 9? Okay? So if you want to use 0, 1, 2, 3, 4, that's fine. Just your 2 and your 3 are going to give you decimals. If you're okay with that, then that's fine with me. But if you want to use these perfect numbers, that's probably what I would do. Okay? So then if I make so this one, if I plot it, that is what a square root function looks like. Can't have the square root of a negative, so it's starting at the 0, 0 and going on that way. So when you transform it, when you do the left one up to, that far left point, there's no arrow on it. That's like your starting point. So like if I want to take this first one, I go left one up to, that'll be right here. Left one up to. Left one up to. So this would be my graph. Okay, so this is the part, there's no arrow on that side. Okay, this is the only kind of problem you're gonna see on the, what was it, page 79?
Yeah.
Yeah. Okay, you won't have any other parts, everything is like this. If you don't know your parent functions or your transformations, that was in the video notes from Thursday. Okay, if you don't do anything else, at least go back and copy those down so you have those to reference. Plus, you're gonna need them anyways to do Thursday's assignment. Well, the page 71 in front of you. Okay? All right.